All right, let's talk about what all those numbers mean on the periodic table squares. So the number at the top is the atomic number, and that always tells you the number of protons, and it tells you the number of electrons, assuming that the atom is neutral. So for sodium, there are 11 positive protons in the nucleus. 8, 9, 10, 11. And there are 11 electrons surrounding. So I'm just going to go 11 electrons for now. The mass number is based on the average atomic mass. So it turns out not every single atom is exactly the same. Just like humans could have an extra finger or lose a finger and they're still a human, a sodium atom could have an extra neutron or one neutron less, or sometimes even more than one, and it's still a sodium. So the average of all the sodiums on Earth, they weigh 22.98977 grams per mole of atoms. And another way of saying that is they talk about AMU. So atomic mass units are basically just based on that the protons and electrons, protons and neutrons each weigh 1 AMU, and electrons are much, much smaller. So when you round the mass number to the nearest whole number, that tells you the number of protons and neutrons. So you can take 23 in this case, minus the 11 protons, and you get the number of neutrons, so 12 neutrons. So I'm going to make those a different color and also draw those in the nucleus. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the most popular or most common form of sodium will weigh 23 because it has 11 protons and 12 neutrons. This little table is a great summary because it has the mass of each subatomic particle, so the particles that are making up an atom. Protons and neutrons each weigh 1, and electrons weigh about 1/2000th of 1. Doing a video, hang on one second. And the charge of protons is +1, the charge of electrons is -1, and the neutrons have no charge. It also has their location and then their job, in quotes, because they don't really know what they're doing. So protons always tell you the type of element. Neutrons tell you, or the neutron's job is to hold the nucleus together, because otherwise you would have positive charges repelling. So neutrons are sort of like glue. And then electrons tell you what's going to happen with reactions. So the last part here is a little example showing, so for example, aluminum, the symbol is Al. Let's look at its square on the periodic table and figure out how to fill this in. So it's number 13. So that means that it's going to have 13 protons, 13 electrons. Its average atomic mass at the bottom is 26.982. And so if we round that, it rounds to 27. And then to get the neutrons, remember we take the mass number minus the number of protons. So in this case, it's 14. And then there's one more to do here. Boron is number 5. So you would look that up. And its average atomic mass is 10.81. So we fill in 5s here, boron. And 10.81, of course, rounds to 11. So then we do 11 minus 5 to get the most popular number of neutrons in the nucleus.